All right, to all of our attendees and the people in the future who are watching this, we have a presentation here from James Greenhill and Eric Duong. So James Greenhill is a platform lead at PostHog. He is a 10-year wrangler of bits at scale. Prior to PostHog, James worked at such firms as Uber, ATG, Jump, SVB, Discuss, and Grooveshark. Eric is currently the team lead for core analytics at PostHog, working on all things query related. Prior to joining PostHog, he studied math and philosophy at Yale while working on building HomeCooked, a social platform focused on shared community dining. Speaking of which, I'm hungry, so I'm going to get a sandwich and let you two guys take it away.
All right, thanks, John. Cool. So we call this presentation how we turned this quaint place into our event mansion. This as in ClickHouse. So what is PostHog? We like to begin by describing what we are, obviously. We go by an open source product analytics suite. And this entails owning the entire event lifecycle. So we try to provide tools that allow you to ingest events, analyze events, and a platform to effectively store those events. You can see some of the features that we have built in might just be classic analytics you might find, whether that's time series analyses, funnels, pads analyses, and we also build in a few extra things that some other platforms might not have, such as session recordings, feature flags, heat maps, and then a lot of export capability. So PostHog was created with the intention of having better data ownership. We wanted to provide an open source platform where you could host it yourself and in effect own your data better. But beyond that, we also wanted to push some more feature possibilities. So we wanted to see how far we could push that relationship between building product and owning data. And yeah, so jumping into some of the defining characteristics of what we had to kind of consider before building was we wanted the platform to be as real-time as possible. That meant the user should be able to analyze their data on the fly and always get up-to-date information and metrics on their product. We had to deal with a continually growing feature set. This meant that the platform that or the technologies that we would use would have to adapt quickly and allow us to adapt. And a little more specific detail here is that we wanted to be able to accept and filter on arbitrarily user-defined payloads. And that means we should be able to allow users to decide how they want their event metadata to look like and then be able to manipulate that in certain ways. And obviously, we, once again, wanted to allow people to host and own their data. So going all the way back, how we started, how PostHog got off the ground, it was written and backed on Postgres, and everything was using the Django. So Postgres was our bread and butter for the first few months. We did most of the queries on there because we needed relational data, and Postgres was great for that. It was perhaps like an industry standard, you might say. Super supported by the community, super easily deployable. We were hosted on Heroku at first. And if you're familiar with Heroku, it actually allows a lot of easy deployment, and you could wrap Postgres into the rest of your app and you'd be able to deploy really easily. So this was great for getting off the ground because any hobby developers that jumped on and wanted to test out PostHog would be able to do that easily. But that came at a cost because Heroku kind of defines how you can deploy these services in certain tiers. Doesn't give you like complete control. So at a certain point, we ran out of that in the sense that Postgres kind of reached its maximum. We were ingesting way too many events, queries were slowing down, and we had to go looking for an alternative.
So yeah, as we were hosted on Heroku, we drove that instance size up to its basically the max. We actually had the largest Postgres instance we could have on Heroku, and we were at a crossroads. Every single event that was coming down the line was causing insights to become slower. Insights are basically is a report inside of PostHog, and we had to do something. Like it was just untractable to stay on Postgres any longer. So we wanted to evaluate an OLAP database that we could switch to. These are the databases that we were looking at. Really what it came down to was three factors. We were looking for something that was fast, had low complexity of management, and had a decent query interface. The speed, because obvious reasons, we wanted this, like we wanted PostHog to be super fast. We want you to go in there, filter on things, and get results as quickly as possible. Complexity of management. We're a small team. We don't have a huge group of people that can manage this. At the time, it was just me and Eric, really. And on top of that, we wanted to make it so that people could deploy this on-prem, which really complicates things. It's very difficult to ship the Hadoop stack to someone who doesn't know what Hadoop is and say, hey, good luck, have fun. The query interface was really important as well. My background is in SQL. I've been dealing with SQL forever. I love SQL. And some of these have stronger SQL interfaces than others. So the candidates. Pinot. We use Pinot at Uber for the Uber Eats dashboard for restaurants. Works really well. Is super fast. Looks like a good candidate. Presto, we also use that at Uber. We use that at Discuss as well. Fantastic. A little bit slower, super scalable. Druid, Airbnb used it. I've never personally used it. Timescale DB, Citus DB, something else that we actually piloted at Discuss, and powers one of our competitors, Heap. Basically a Postgres fork that is super OLAP. Has a columnar data store on the back end. Pretty interesting looking. And then ClickHouse. ClickHouse is an interesting one for a number of reasons that we'll get into soon. So why ClickHouse? We first started out looking at a ton of benchmarks. The first thing we wanted to do, we were pressed for time. We weren't able to benchmark everything perfectly, but we did make our best effort in doing so. We looked at a bunch of benchmarks out there, taking them with a grain of salt. Everything seemed to be glowing around the ClickHouse space though, especially around just the sheer speed and size of data on disk. Secondly, we looked at people that were operating ClickHouse at scale, as well as the other ones. But Sentry, I have a lot of good friends at Sentry. They've been using it for a couple of years at the time. They had migrated off similarly from Postgres and Redis as their backend data store. And they use it for pretty much everything. So I reached out and said, hey, like, would you do this again? They were like, yes. Cloudflare had just published a blog post saying that they were consuming 6 million requests per second for their analytics product for their front end. It looked really sharp. Uber was just piloting it for logs, and of course, it powers Yandex Metrica. Pretty decent sized product and seems to be relatively successful. So what we ended up doing, set up a test cluster, and we were blown away by the speed and the ease of use and the ease of setup. I mean, this was basically RPM install, and then we were good to go after we ingested the data. So how did we make this decision? ClickHouse powers Yandex Metrica, like I mentioned, 20 billion events a day, over 13 trillion records in total. One of the really defining factors here is reports are built on the fly from non-aggregated data. So if you look at most of these other systems, it's kind of par for the course to have some sort of DAG orchestrator. So like you'll directed acyclical graph of tables that feed your product. So you'll have the raw events come in, then you'll process it into something a little bit more tractable, and then process that into something that will be consumed directly from some sort of feature on your application. This is how most people do it. It works great. You'll use Airflow for it. And you know, it makes things work relatively well. Backfilling is very, very straightforward. The problem is that does increase the complexity. We're a very small team. We wanted to get this out. Also, again, we wanted to package this up and ship it to people. That is a lot of extra complexity. So column oriented, which is pretty par for the course. Written in C++, this is a huge advantage. We did not have anyone on staff that was like a super JVM expert. We didn't want to have to deal with tuning. We just wanted this to work. Also, it makes it easier to ship in a container. Tightly coupled compute and storage. That's another complexity thing. Like I would love to have this split up, but because they're so tightly coupled, it's super fast. And one last thing, we don't have to like HDFS to manage or anything like that. All right. What makes ClickHouse special? Excellent compression, like I mentioned, processes data from disk, which is a really, really nice part. So things like Presto, which I love, really require everything to fit in memory for a query to run. ClickHouse does not. So this lowers the barrier to entry for our customers that are running this on-prem. They can have instances that have lower memory, and then their queries will just run a little bit longer as it processes things from disk, which is really, really nice. Vector computation, coming from a world of MapReduce, is just really nice. Near real-time data updates. We'll get to this a little bit later with the engines that we use, but this is pretty sharp. Sorted data allows primary and secondary indexes, data skipping indexes, no query planner, which means deterministic query execution. Lovely. What we see on our end is generally what we will see forever. We won't see the query plan completely change because some summary statistic of the underlying data changes. We're a small team. This is nice. Support for approximated calculations. Eventually, we'll have some sort of samples on these. We don't use this yet, but it's nice to know that we can use it. Easy replication and sharding. So as we grew our production, our PostHog cloud cluster, we needed to replicate and shard these instances, and it was relatively straightforward to get that done, which is nice. More on that later, though, because it's not all sunshine and rainbows. What makes ClickHouse painful? Mutations are not really supported and very expensive. So very early on, because we were syncing from our source of truth data set, which is Postgres in our case, to ClickHouse for analytics, we have mutations, and specifically on the person. So we store all of the person information. The source of truth there is on PostHog or Postgres. And we basically, every time that's updated, we wanted to update that in ClickHouse. And so we're using mutations to get that done. Unfortunately, what happens there is mutations rewrite entire sections of a partition, sometimes the entire partition, which is very hard on disk. And if you have a bunch of these mutations queued up, ClickHouse is very good at reading like a large or small number of large files versus a large number of small files. These get tacked on as small files, slows everything down almost exponentially. So we actually had our first like degradation of service because of this, because we were abusing the mutations. We were doing about 100 mutations a second, which is pretty bad. We did fix that though. Transactions are not supported, which is kind of a bummer in terms of replicating a source of truth database into ClickHouse. Sparse index is not a real index, which means that if you wanted to grab a single event or a single person from ClickHouse, it is a little slow. And resharding is terribly painful because right now it's very manual. You basically have to recreate the entire set of tables that you want and then copy them, and it will reshard them as it gets sunk into the new location. We've had to do that a couple of times to reschema tables as well as to reshard tables.
Okay, so I'm going to talk through some of the points that I previously mentioned and how ClickHouse kind of addresses all those points. Briefly covered already in the previous slides, but this is more explicit. So users should get as close to real-time results as possible. With ClickHouse, we're able to do that because while we did that on Postgres for a little bit, once we got to a certain scale, that was untenable for us for staying on Postgres. So we switched ClickHouse, and because of the performance boosts and because it's a column-oriented database and how we're able to leverage that, we are continually able to produce real-time results or near real-time results with some clever caching here and there, but otherwise, as events come in within that time frame of just ingesting them, we're able to put them into our analytics. And then there's also a continually growing feature set that we have to deal with. And this is great because ClickHouse has pushed to build a very, very familiar SQL syntax. There are some sharp edges where certain functions don't exist here and there, but more often than not, you'll recognize that the SQL syntax of ClickHouse is like any other, like the standard. Yeah. And the next one is, once again, a very specific detail, but very important for some of the later optimizations we're going to talk about. The system should be able to accept user-defined properties. And this is kind of like a dynamic key value store you can almost think of. And this proved to be a bit of a problem, but another specific feature actually in ClickHouse, such as materializing columns, allows us to do these queries in a very efficient manner, even though it's user-defined properties, even though we're still trying to produce real-time analytics. And the system should be as easily deployable as possible to cater to users who want to own their data. And once again, ClickHouse offered another thing called Kafka engines that allowed us to push through events very quickly, allowed us to deploy with very little overhead. And this, once again, also allows us to package ClickHouse and PostHog into a very deployable or a very redeployable package. So diving into the user-defined properties problem, we did some experimentation even after we decided to go ahead with ClickHouse. And this was a point of concern because users can define as many key values as they want inside their event payload. And we needed a clever way to store that. So the most obvious way was to just kind of store it in a string, store the JSON in a string, and kind of parse that in certain ways. So one of the ways we tried to parse it was matching arrays, meaning we store all the keys in a sequence in one array, and then we store all the values in sequence in another array. And then when you index, you can actually match them up together. This didn't prove to be useful. And when we say slow, unfortunately, I don't have the exact measurements here, but you would start to see problems even with a few order of magnitudes in event data. So going from like hundreds of thousands to millions to tens of millions, we did all of those measurements, and you'd already see some issues. And the second solution we tried was a key value lookup table. It's effectively a table with three columns, one with the entity ID of whatever you're looking up, and then keys and values. So you could just join that table into wherever you want to match up key values. Once again, wasn't really up to our standard or up to what we would need to produce real-time results. So we realized we could just stick to actually leaving it as a string and using another ClickHouse provided feature called JSON extract string. And this was effectively just parsing the string, parsing a JSON string into discrete values that you need. It was still expensive, as we'll get to later, but it did the job for a while, and for a long while, over a year or so. And then we kind of recently pivoted, but you'll see how we did that. Yeah.
Yeah, and the other one is basically in our old world, we had a entire relation for this feature that is kind of unique for PostHog, which is auto captured events. So when you're using the JavaScript library with PostHog, you don't actually have to instrument every event that you want to capture off your website. What you can do is you can turn on auto capture, and it captures the entire DOM hierarchy of what you click or interact with on your site, which is quite nice. But the problem is we need to expose that somehow so that you can query on it. So you can say, like, I want every click that happened on this element in my site. And we had to get kind of clever, because before what we would do is we would do this relationship using the ORM, and we just couldn't do it using ClickHouse. So what we ended up doing was we leveraged regex, surprisingly. And we have our own serialization for serializing the hierarchy of the DOM, and we compile a regex to extract out whether or not you're matching the elements that you want to get out. So if you want to like pull out a CSS class or an element ID, you can do that using this. And luckily, because ClickHouse uses the Google RE2 library, it's constant speed. It's a subset of like true regex functionality, but the nice thing is it is constant speed depending on the size of the string that you're looking at, and it is fast. ClickHouse does this, like we were doing some benchmarks on this, and it is just outstandingly fast. So that's really nice. So the real lesson there is that ClickHouse just offers us a ton of functionality where they've obviously optimized for speed everywhere. And the other thing that we learned is, again, don't mutate. Please don't mutate when you're using ClickHouse. It's really good to get out the door, but have a plan to get off that as soon as you can. All right, so making the switch. How did we do this with zero downtime and also preserving a decent customer experience? The way that we did it was we ended up double writing. So we warmed ClickHouse up with all of history, and then we started double writing everything to both, just to make sure that the pipelines were good. There were no weak spots. We also introduced Kafka at this point. We were using Celery before, which was a huge upgrade, both in reliability and just in durability. It meant that we would have a safe place for our events should something go down, and we would have a lot bigger buffer. Yeah, so we just started double writing, and we used one of the tools that we had in our tool belt that we built specifically for this migration, actually, called feature flags. Very clever name. So feature flags allowed us to very selectively launch each of our features powered by ClickHouse first to our team, and then slowly to all the teams that were using PostHog, which gave us a lot of confidence. It meant basically that we could move fast. We didn't have to worry about breaking things for everyone. It just made it a lot easier to do. Like once that was all done, all teams were switched over to ClickHouse. We turned off Postgres ingestion entirely and dropped the table. And it's been history ever since. We still do support Postgres. We have a couple on-prem deploys that have that, but that is slowly ending. We're basically migrating everything over to ClickHouse, even for on-prem deploys. So you might ask, how do you deploy ClickHouse for cloud? And the way we do it is we have a custom i3 EN12 extra large, several instances with local NVMe storage, and we use CloudFormation and Ansible to make that repeatable and deploy these instances. So we can add and remove instances as we need if an instance goes down, et cetera. But the more interesting thing, I think, is how we do this for customers that want this on premise. So if you're someone who is very sensitive about your data, maybe you're in the medical industry, you don't want the data to leave your cloud or your infrastructure at all if you're using Kubernetes, you can deploy PostHog using a Helm chart. And in that Helm chart, we use this thing called a ClickHouse operator, which is developed by Altinity, and we love it. It makes our job so much easier. If we had to do this ourselves from the beginning, it would have been really tough. So this is basically something where it creates a CRD on a custom resource definition on Kubernetes. And we just say, we would like a Helm chart backed by this type of storage, this size, please. And it boots it up for us. And we just leverage that pretty much everywhere. And yeah, that has been something that has been fantastic for us and our customers. All right, so back to our cloud. We provision pretty large, and we've just been thrilled with how well ClickHouse has been able to use these resources. So we have 4 production nodes, 2 shards, 2 replicas, 48 vCPUs each, 384 gigabytes of memory, 4 7.5 terabyte NVMe ephemeral storage on each of those nodes. We have those in RAID 1.0 because we don't want to lose data and we also want to be fast. 50 gigabit network for all of those. And then we have 2 instances that are backup nodes. So they're smaller. They don't get hit with production traffic. They're basically just reading from, they're just replicas. And they have 8 terabyte EBS GP3 instances for storage that we snapshot daily. We also have point in time recovery off of Kafka. We have a write-ahead log. And we sync all of that to S3. So should something go down, we can recover from a snapshot and then replay the Kafka logs from that point and basically get point in time recovery. So total, we have 208 vCPUs, 1.6 terabytes of memory, 30 terabytes of NVMe, and 16 terabytes of GP3. Eventually, we'll have tiered storage for this as well. So right now, everything's hot, but eventually it'll be hot, cold, and then S3. Which will make it so that we just have we can keep history and the cost gets progressively cheaper, but it's still available to our customers. This has worked out really well. One nice thing that we've seen is ClickHouse loves to use the page cache, and having this much memory makes it very fast since most of the data that we're serving is hot. And yeah, it's been not bad. This is our Helm architecture. I'm not going to go over this or trace anything, but if you want to talk about it, please reach out to either me, myself, or Eric. The table engines, my favorite part of ClickHouse, besides everything else. So ClickHouse enables you to basically create a bunch of different tables backed by all of these different table engines. The merge tree itself is really clever, really basic. I love the simplicity of it. It just sorts things on disk, and then you can select how it sorts things on disk, and that's effectively your index. Lovely. It's very easy to have people wrap their heads around it. These other ones take that just even further. So the replacing merge tree we use for events, it dedupes for us. It's great. We've used this for recovering things. We've used this where we know we're going to introduce duplicate events, and ClickHouse just eventually takes care of the dupes for us. Collapsing merge tree, we use this to introduce mutations after we actually got rid of the alter table mutations that ClickHouse supports. So this allows you to introduce a sign on every event, or in this case, it was person, which is a tombstone. So you say sign -1, and it cancels out another element in the table that may have a sign of +1. It does a sum. It's really interesting. If you want to look into it, I have a link in the deck to the documentation. Version collapsing tree is the same thing, except for you can select what wins, what column it will win as a term in terms of the last write if there's multiple sign +1s. The Kafka engine is probably my absolute favorite thing. When we first started adopting ClickHouse, this was actually fresh. It had a bunch of sharp edges, but it still worked great. So what this does is it allows you to wrap a Kafka topic with a schema, and you can select from that as if it was local storage, which is really interesting. And every time you select it, it pushes forward the consumer group offset. So what's interesting about that is you can wrap that in a materialized view, and the materialized view just on a loop will consume from that Kafka back table, and you effectively have a data pipeline. So if you just have a couple of materialized views off of that, there's your DAG right there. You don't need to have an Airflow or anything like that, which we might need eventually for something else, but this is a near real-time data pipeline that services our customers all in one spot with no external dependencies. It's really quite nice. Distributed tables, wrap tables, and this is how you do sharding. I kind of like it because it makes it easy to comprehend what's going on, and it's very tunable. Materialized views, I kind of talked about that with Kafka, but it's a view that materializes. You can select the engine for the table that it syncs data into. It's fantastic. And S3. There's a couple other ones that are really interesting too that we will probably use at some point. There's an HDFS one. There is one that you can hit an HTTP endpoint, which is kind of neat. So you could technically have a view that does like a put request using this endpoint one, or you can make GET calls. It's really weird. But yeah, I'm super bullish on the engines and how this makes ClickHouse extensible.
Yeah, cool. Everyone's favorite ORMs. So this was our decision to not use an ORM when we converted from Postgres to ClickHouse. Again, previously relied on the Django ORM to query data, but moving forward, given the complexity of our queries that we wanted to, you can imagine writing like the funnel query, trend query, any of those things have pretty intense complexity if we're building them and trying to create, trying to return data real time all the time. So for more control, ease of debugging, and less interfaces to manage, we decided to stick with just writing raw SQL, and that's where we've been. Yeah. So some of the characteristics of our queries we thought were interesting to note. So once again, syntax is familiar. Not everything's familiar though. So for example, the date functions or like truncating dates aren't necessarily the same when you're using other, it doesn't match any other SQL standard as far as I'm aware, but the syntax is similar enough where new engineers, new people who are joining the project don't have the biggest trouble looking into how to use it. The more important or more significant sharp edge would be that some features that you might take for granted don't exist. So CTs or common table expressions didn't exist, or they were very limited at first, where you couldn't really actually, you could use them at like the top level query, but you couldn't actually refer to them in the subqueries. Again, if I'm remembering correctly. And then window functions also barely existed, but we went ahead and used them because we needed them to create some of our queries, and they were just fine, but they're definitely just on the cusp of being released. And yeah, so the ones that do exist are powerful. So these window functions came in handy for those funnel queries. Another interesting note is that ClickHouse does push array functionality a lot, which is really awesome. We were able to change a lot of logic into array processing, which was less of a headache for us and just pretty fun to use. One of the running jokes is that when we want to implement something, we might just hop into ClickHouse documentation and see what kind of cool function they have going, because a lot of times they have it implemented quite well and efficiently. Yeah, and ClickHouse does provide joins, so our data is relational to some extent, and this helps us make those queries. Some notes on testing to keep the ship sailing. We rely heavily on integration tests because we still kind of have a decent amount of shifting sands on how we're building queries. So we have these high-level tests that that take in a lot of the parameters that a user would put in, or essentially put in based on the interface. And we do this to just kind of test how the query is built and if the results are correct. We recently added snapshot tests to really lock in place queries that we don't really want to change at all. And then very recently, one of our engineers actually added in ASV, which is airspeed velocity, another open source tool that we use to run benchmarks. This is pretty cool because we have like a fresh deployment that's loaded, well, that's preloaded with data at scale, and then we can run our benchmarks on them whenever a PR is related to changing a query. And this has helped reduce a lot of regressions in terms of performance, because before we had regressions in other cases, but we'd sometimes find ourselves having a weird variability in query runtime. So this has helped smooth that out quite a bit. All right, so one of the more interesting learnings, or very recent learnings, that kind of showcase ClickHouse at its finest, or some of the features of ClickHouse, was that our queries against those event properties were slow, those user-defined properties that we're talking about. And you could see this flame graph. It's kind of zoomed out, so I can't really see what it's circling. But this kind of shows how a query, the processing of a query is happening. And you kind of look through the layers, you can see based on the width how much CPU processing exists for across like the time that the query is running. And you'll notice, thanks for zooming in, you'll notice the JSON extract function, which is the one I previously mentioned, was taking up a lot of processing time. And we didn't want this to occur, obviously, and we felt that this could be changed to some extent. And so our solution was using materialized columns. James, slide. Yep. So using materialized columns, and what this meant was you can actually add a column that is based on a calculation upon ingestion on a table. So we had an event table, we had some data that you would ingest, and you can actually set a predefined calculation that would push that data into the materialized column. So we did this for high volume properties. So we actually did some data analysis and added this analysis that would automatically check how many properties certain teams had. And if there was a very huge hotspot of a property, we'd automatically materialize that. And then because it was pre-calculated, we didn't have to perform that expensive JSON extract string. And we found this type of improvement and reduction in reads. And that turned out to be a huge win for our query performance. So looking into the future, these are just like a kind of quick off the top of our heads ideas of what we might look to do, what's exciting. So our queries are really huge. We have kind of teased the idea of maybe building functions at the source. This would require kind of forking ClickHouse or maybe PRing to ClickHouse. But that would maybe provide some cool manipulations on, or cool optimizations on how we query. But that's an idea that we've had. Materializing and pre-calculating more data. So we definitely don't leverage ClickHouse to the max. We kind of made that conversion late last year to ClickHouse and have used a decent amount of its powerful features. More are coming out. Hope to keep taking advantage of those.
Yeah, and like what Eric was mentioning, basically we've bet the house on ClickHouse, and so something that we're looking to do in the very near future is to hire an engineer that would be basically full-time working on building out features and establishing a relationship with the ClickHouse community, so that we can upstream things that we want to see in ClickHouse ourselves and maybe steer the roadmap a little bit. Because so far it's fantastic. There are a lot of really good analytic functions in there, but there's always room for more. And we already kind of have that itch to scratch already. But other than that, Materialized PostgreSQL engine experiment that's currently experimental. This is something that we've been testing internally. As I mentioned earlier, one of the big things in any data flow, any type of data warehouse where you're trying to sync data from your source of truth. In our case, it's our OLTP database, which is Postgres, which is a source of truth for persons, into your OLAP database for doing analytical queries on. Keeping that in sync and not having drift is really tough. We have a lot of engineering around it to ensure that that does not drift. Even then, it's not perfect. So having this would be a turnkey way of syncing data between Postgres and ClickHouse. And like this would be huge for almost everyone out there, not just us, but for us, it would be super, super nice just because we could keep a lot more transactional data in Postgres and have it available for querying in ClickHouse, should we want to report on it. Also, something that we're looking into currently is for very large customers that don't have the engineering power or resources to allocate towards managing their own ClickHouse installations, using Altinity hosted ClickHouse or Altinity Cloud. So this is something where a company may want to, for whatever reason, want to host PostHog locally. This gives them an outlet for having someone else manage the ClickHouse cluster, which could be a really nice synergy. And on that note, we are perfectly on time. Questions?
You could always reach out if you have any other questions that pop up later.
Yes, in fact, while you guys are there, could you want to replug your pluggables?
Oh yeah, so PostHog, of course, is that we should have had a slide for this. We're hiring. So if this is something that you would like to work on, either on the ClickHouse side, the analytics side, the front end side, check our front end. It's pretty nice. We have the creator of Kia, which is a wrapper on Redux for state management for React. We have a lot of really cool people that work here, and we're dealing with quite a lot of data. And it's a relatively small team. Like the number of events per team member has to be like way up there. So yeah, if that piques your interest, please reach out. Go to posthog.com and yeah. reach out to us. Or you could reach out directly to either me, james.g@posthog.com, Fusion Tech, everywhere like Twitter, whatnot, and Eric.
Eric@posthog.com.
It's easier to remember. You can also do James at PostHog. It's going to go to the co-founder though, but he'll get a kick out of it.
I got excited. I thought that you had the Eric tag on Twitter. I was about to say,
Oh, that'd be
nice.
pretty good.
Oh no, that would be great.
If there are no questions, I will pose a question that we ask everyone, which is, does pineapple belong on pizza?
I mean, look, first of all, my thing is that I'm not going to yuck on someone else's yum. So let me just start with that. So that said, I'm perfectly fine with it. Pineapple with some pepperoni, pineapple with some ham. It works out well for me. My only issue is that I have 4 little sisters who believe that I don't like coconut. And I think that's why every time I show up at my parents' place with the hand dipped chocolates for Christmas time, all the coconut mounds are gone. And my sisters are like, John, it's because you don't like coconut. I'm like, yes, I do. Yes, I do. You don't like German chocolate cake? That has nothing to do with this. It's a different animal.
That's
anyway.
amazing. All right, cool. Well,
you guys on a pineapple since we're here.
Oh yeah. Okay. So for me, I believe pineapple is destined for pizza. This is a divisive thing that we ask everyone that joins PostHog.
I'm a fan. I don't know about destined, but I'm a fan.
It's so good. I love a Hawaiian pizza with jalapeno.
Oh, that actually sounds good. I'll have to try that.
It's
all
pretty
right.
Good.
Well, if there's no other questions, I'm going to go ahead and end this out. Thanks everyone for attending. For the folks in the future, let us know if the aliens have landed. And Eric and Mr. Greenhill, thank you both very, very much for attending, and I hope to talk to you soon.
Thank you. Thank you for having us.